Hi, and welcome back to the Ninox Learning Series. My name is Andy. I'll be your instructor. I'm a Ninox programmer and trainer. And today we're going to continue our discussion about programming in Ninox, creating formulas and coding in Ninox to automate processes. Now, in our last class, we discussed the if-then structure, which allowed Ninox to make decisions based on an evaluation of the current state. If this is the current state, then do this. If not, or else, do that. We call this the if-then structure, which is an excellent programming tool when we want to evaluate a single current state. In this class, we're going to evaluate a new structure called the case or the case-do structure. This structure will enable us to program the details of how to evaluate a more complex current state and make the correct decision as to what to do next. So let's go ahead and get started. Now, for this class today, I've prepared a database consisting of one table and just a couple of fields. The data model really doesn't matter. But what does matter is our ability to instruct or train Ninox to make the right decision in the right situation. Now, you see two examples on the screen, and I want you to focus on the first example. We see one choice field that offers us 6 choices. Based on the choice that we make in this choice field, these two fields will display a certain value. Now, these fields do exactly the same thing, and they will display exactly the same results based on the selection made here. If we choose 1, it'll do the first thing, the second thing. Choose 4, it'll do the fourth thing. 6th, it'll do the 6th thing. And if we make no choice at all, both fields will indicate that no choice has been made. Now, why have two fields doing exactly the same thing? I want to demonstrate the power and value and economy of the case structure compared to the other decision-making structure that we've spent a lot of time on, the if-then. Let's first look at the if-then structure and how it evaluates the current state of the choice field and presents the proper results based on what it finds in the choice field. We go into the formula and we see a series, in fact 7 nested if-then structures or loops. First, we determine the numeric value of whatever is selected in the choice field, and we assign that numeric value to the letter C for choice. If C is not null, if there's something in the choice field, then do one of the following. If the choice field equals 1, do the first thing. If it does not equal 1, see if it equals 2. And if it does, do the second thing. If it doesn't equal 2, see if it equals 3, or 4, or 5, or 6. And if it doesn't equal any of those things, then simply display the result, no choice has been made. Now, when we look at this, I don't know why we have that void in there. I guess I had an extra else statement. We'll go ahead and get rid of that. As we look at this structure, we see 28 lines of code. And it's a little bit complicated as we start nesting one if-then inside of another. But again, 28 lines of code to determine which single choice was made in the choice field, and to then determine what to return based on that choice. Compare this set of structures, this set of 6 if-then structures nested inside of each other, to the exact same result being generated from a case structure. 16 lines of code, little less than half the code, and a much simpler decision tree. We see the beginning structure, which basically says determine what choice was made, and in case the choice was 1, do this. If it was 2, do that. If it was 3, 4, 5, or 6, do these things. And if no choice is made, indicate no choice is made. Now, these are very simple decision structures with very simple results. But the point that I'm trying to make is still clearly demonstrated here. The first point is this: 16 lines of code is smaller than 28 lines of code. Small things run a lot faster than big things. Now, the speed penalty that we pay, excuse me, if we go with the if-then structure is compounded by the fact that not only do we have almost twice as much code to store and process, but Ninox will go through each individual line until it finds a match. Therefore, if C equals 5, if the fifth choice has been made, Ninox will first determine, is C equal to something other than null? If it is it a 1? No. Is it a 2? No. Is it a 3? Not a 3. Is it a 4? Nope, not a 4. Is it a 5? Yes, it's a 5. But it will look at the 4 previous evaluations before it determines it was a 5. So we have all of this code, and in addition, this much code is being executed. These 14 lines of code are being executed when the choice is a 5. Compare that to this structure. In the case structure, not only do we have significantly less code, but at such time that the fifth choice is made, it will evaluate this line of code and those 2 lines of code. And that's it. 3 lines of code to deliver the same result that the if-then structure needed 14 lines to deliver. Small things run faster than big things, and the case or switch structure that we're looking at can be much smaller and more compact than the if-then structure. But in addition, programs that have a lot to do take longer than programs that have very little to do. This if-then structure has to do 14 things if the choice was the fifth choice. If it was the sixth choice, it has to do 17 things. However, in every instance, in the case or switch, it will never have to execute more than 3 lines of code. So we have a smaller, more compact package of code, and within that smaller package, we need less code to get the exact same answer. Both the if-then structure and the case structure will get us to the same place. But in this case, the case or the switch structure is the airplane. It's going to get us there a lot faster with a lot less effort. So now that we understand some of the values of the case structure, let's now begin to understand how it's built, the syntax of how we use it, and when we use it. So again, this first example was presented here so you could see that the same result can be achieved in a case or a switch that is delivered in an if-then with significantly less space being taken up by the size of our database and with fewer lines of code having to be interpreted and executed. Now, let's be honest. 14 lines of code here, 28 lines of code there, that's not a lot. But when you start building more complex databases, any place and every place you can save a kilobyte here or a megabyte there, I encourage you to do that. This is what we call efficient programming. These are best practices for writing code. Write the least amount of code to get what you need. Take the shortest path to your destination. If someone's offering you the jet plane, don't tie up your shoes and start walking. Now I want you to focus your attention on the second example, and this is where we're going to spend the bulk of the remainder of our time in this class today. In this structure, we see another example of the values and benefits of the case structure versus the if-then structure. Keep in mind, in example 1, current state consisted of one thing and one thing only, one choice and 6 options within that one choice. The current state consisted of one field. And even then, the case structure could get us the right answer with 3 lines of code versus 17, 18, 19, or 20 lines in the if-then. And that was for a current state evaluation consisting of one field. When we start having to evaluate a current state that consists of multiple fields, the economies, the speed, the power of the case structure is magnified and amplified exponentially. So let's look at this second example where we have created a slightly more complex current state to evaluate. Let me show you what I mean. We have this field here that allows us to select a travel method, and our options are land, sea, and air. Based on the method we choose, this field down here will tell us what kind of vehicle we should use. However, we have some interim choices to make. If we choose land, we have to choose if we want to travel by automobile or by train. And we can see the vehicle of choice changing based on this decision. Now, this field has to evaluate twice as much current state as we had to in example 1. It has to determine what choice was made in this field and what choice was made in that field. Now, if we choose C, we've got 3 more choices. Small boats, and that's a pretty small boat, medium, and large boats. And if we're traveling by air, if we're going a short distance, we can use a helicopter. More than 250 miles, we're probably going to want to take the plane. So let's see what we've got. We have 3 options here. 2 more options here is 5. 3 more options here makes 8. And 2 more makes 10, combined with the fact that we may choose no method of travel at all, which gives us 10 different options that can be chosen spread across 3 different fields in the current state. To do this in an if-then structure, to be able to choose the method of travel and then display the proper option field for land, sea, or air travel, would take almost 50 lines of code if we did it with nested if-then structures. Approximately 50 lines of code. Compare that to the case structure, which is built into the recommended vehicle field, which takes up all of 27 lines of code. Literally half. 50% less code necessary, and fewer lines are being evaluated. So, we now understand why this structure is so valuable to us. It takes up less space, it runs faster, and it does both of those things even in more complex environments. So, let's start building case structures. We're going to start by building a very simple one. And again, as always, I encourage you to follow along and practice along on your computer. Hit pause anytime you like. And then when we're done building a couple of basic case structures, we're going to return to example 2 and see how we embedded multiple decision-making structures into this more complex environment. I am now going to create a new table. So we have a nice clean blank sheet of paper in which to work on this new structure. I'm going to have one choice field and the formula field. The choice field is going to have 4 choices. Choice 1, which I will copy in order to make choice 2, choice 3, and of course, choice 4. Now keep in mind, when working with a choice field in Ninox, you always get two results based on the choice you make. The text result, which in this case is going to be choice 1, 2, 3, or 4, and the numeric result, which in this case will correspond to the digits, the numbers 1, 2, 3, or 4. Just keep that in mind because this is going to be very important in just a few moments. Now, what I would like to do is have the formula field return a value, a different value based on which choice I make. So we're going to go into our formula field and we're going to build a case structure. Now remember, as I said in our last training class, there are 4 looping or decision-making structures: the if-then, the case of, the while-do, and the for-next. In the last class we looked at the if-then. Today we're looking at the case of, and we're going to sprinkle a little if-then in there and combine them. In our next class we're going to look at the while-do and then the for-next. So as we go through these classes, the last one, this one, and the next 2, we're going to cover all the decision-making and repetitive looping structures. The case structure is the only one that does not begin with its own name. The if-then structure begins with if. The while-do structure begins with while. The for-next structure begins with for. And of course, the case structure begins with the word switch. Always in all lowercase. Now, the switch is the choice, and it ends with the word do. In the if-then structure, we could evaluate a current state that resulted in one of 2 values, but only 2 values, a yes or a no, a true or a false. The test would pass or fail. In the case or switch structure, we can evaluate any number of potential or possible results and act on each result independently. And the value here is, if the result is maybe the 8th or 10th or 20th one, Ninox will not evaluate every previous result just to find out which one was right. If there are 18 choices and the user selects the 17th, this structure will go directly to the 17th area and do exactly what is stated there. It will not waste any time determining if it was 1 or 2 or 3 or all of the values through 16, because of course they were false anyway. So we're not going to waste time taking tests that are going to fail. Now, the switch tells Ninox that there are going to be multiple options available. The option that you do is going to be based on the numeric value of the choice that was made. The structure goes on to say that in case a 1 is chosen, do these things. In case a 2 was chosen, do that. If the 3 option was made, do these things. And then finally, if it was the 4th, do these things. And then we end the structure. This is the basic definition, the basic syntax of the case structure, or what in Ninox is referred to as a switch. The switch can go any one of 4 ways. Which way it goes will be indicated by the numeric value of choice. And once the choice is made, do the thing that corresponds to the case or the choice that was made. Key things to remember here. You do not need to end the first line with the semicolon. However, you must end every case statement with the full colon or the stack. This structure will always begin with the word switch in lowercase. It will always end with the word end, also in lowercase. So let's look at how we can create a simple switch structure. In case of 1, say bad. In case of 2, say better. If it's 3, it's pretty good. And if it's 4, it's fantastic. And as we know, Ninox is not going to leave those blank lines in there, so I'll go ahead and get rid of them. Now, we will select OK. And now let's go back and look at our structure. As we are now used to, Ninox will format it with the indentations and the colorization as necessary. Our keywords, as we have now learned, and the keywords are the words switch, do, case, and end, will be in purple. Text, standard static text, enclosed in double parentheses, always is red, leaving us with the name of the field, and field names and table names are always in black. Numeric values, numbers, in green. So what we're saying here is, you, Mr. Ninox, need to go find out what number they chose. Based on that number, go directly to that case and return the value that we see there. Let's see how it works. We'll go into case 2. I'm going to leave administrative mode. Now, no choice has been made, so nothing is being returned. If we choose 1, that's bad. 2 is better. 3 is pretty good. And of course, 4 is fantastic. So it's working exactly the way we want it to. Now, again, we could have just as easily put these 4 results, not good, good, better, fantastic, right into the choice field. This is not a practical application we're building. This is a demonstration application to help you understand how to use this very powerful and equally economical case switch structure. Now, when we looked at the if-then structure, there was the option to give Ninox a trapdoor, a way out if everything else failed. If this is true, then do this. If it's not true or else, do that. In the case structure, we have a similar opportunity to tell Ninox what to do in case none of the expected choices were made. Now, in this particular example, the reason none of these choices would have been made is because the choice field was left blank. Because this is not a required field, and because there is no default value specified, we see that empty, null, no choice whatsoever is a valid response. If you want to guarantee that a choice field is not blank, go ahead and make a default choice. And if you really want to bring attention to the blank, make it required or a yes. Now, every time a record is created with a choice field, the default choice will be made, and now you see there is no option to leave it empty. But I'm going to go back to the way things were a moment ago because I want to show you how to create that trapdoor. What to do in case none of the cases is actually equal to the current state, or the choice was no choice at all, the null value. What we can do, but it must always be the last thing we do, is define one more case. And this will introduce us to another keyword, and that word is default. In case it's not a 1, a 2, a 3, or a 4, go ahead and say, make your choice. Now we see, a moment ago, when the choice field was blank or null, when no choice was made, the formula came back with nothing. Now when it's blank, it is giving us the instruction, make your choice. And when we make our choice, it then will respond accordingly. Let's look at a couple of other things that are important to understand when creating and using the case or switch structure. Again, I'm going to go into the code editor, And let's look at a few things. First of all, a case structure must return the same type of result in every case. There are really 5 cases here. The case of choice 1, 2, 3, or 4, and the 5th choice is no choice at all. However, when we had it set up like this, bad, better, pretty good, fantastic, and make your choice, no matter what the user selected, no matter which case proved to be true, the result was always a text string. In case 1, return these letters. In case of 2, these letters. If I tried to return this number in case of 3, we would get this error. Return types of case, statements do not match. You cannot return text in some situations and numeric values in others. Now, if we wanted it to return all numbers, that's perfectly fine. There's a very simple case structure where all of the returns are numeric, and in case none of those work, just return the 0. A perfectly valid structure, a perfectly valid syntax in the switch or case structure. What we cannot do is mix results. If in case of 1 it returns text, then every other case must also return that same type of result. And instead of fantastic, we'll just say excellent. Return types don't match. Don't forget, folks, 0 is also a number. So we've got to make this one make your choice. And there we go. Some other things to look out for. If you see the symbol expected, keep in mind this is a rare block of code because the entire block of code is correctly written without a single semicolon. As we have started learning how to write code and build formulas in Ninox, we've learned that the semicolon at the end of a line of code is like the period at the end of a sentence in the English language. Well, we see no semicolons here, and that is perfectly correct. What we do see, however, is the full colon, or the stack, the 2 dots, one on top of another. If you ever see the symbol expected when building a switch, there's a good chance you have left out the stack or the full colon. If you forget the end statement, again, it's going to give you a symbol expected, but it's going to tell you that the default end is missing. So we can do that. The other thing to keep in mind is the default option must always be the last option. Default must be the last statement. Here, we've indicated the default is the first possible case. That is never true. The default is always the last possible option. And like all keywords, default is always in all lowercase letters. We start with switch. We evaluate something that distills down to a number. And based on the number chosen, we do one of the following. And if none of the things we were told to do get done because there is no number, there is no choice, then do the last option, which is the default option. And finally, end our structure. As we learned in the previous class, variables declared within a structure have a lifespan of the structure itself. If I were, in case of 1, to let x equal 1, that's perfectly valid. I can set that variable. And we now see the next issue, which is when we have compound case results. This is what we call a simple case result. In case of 2, do this one thing. In case of 3, do a different thing, but still one thing. In case of 4, or no choice at all, do one thing. That is a simple result. In case of 1, do multiple things, do more than one thing. That is called a compound result. And there we go. All of the rules that we've learned so far in coding apply inside the result of a case. And Ninox will automatically enclose all of the lines of code, if there is more than one in a case result, in parentheses. You do not need to type them in. Ninox will add those along with the indenting automatically. And as I said before, when you have multiple lines of code, as we do here, within a single case return or a compound return, those lines of code must be punctuated and completed or ended with the semicolon. In case it's a 1, 2, 3, 4, here's what we do. And if it's none of those things, we do the default. Where do we get the 1, 2, 3, or 4? It is the numeric value of the choice that is being made. Now, let's go back to that second example that I showed you a moment ago, where we were indicating some characteristics of our trip, our journey, and Ninox was then recommending the vehicle that we should use based on air, land, sea, long distance, short distance. Do we want a big boat? Are we going with friends? Or a little boat because we're going by ourselves? This is a complex or a compound current state in example 2. More than one thing has to be evaluated to get a complete picture of our current state. And only when we have evaluated everything and we have that complete picture are we going to know what to do next. In case of land, choose between train or automobile. If it is sea travel, we can pick the size boat. And again, if it's air travel, short distances in our helicopter, long distances in the airplane. Let's look at this complex switch or case statement. And we see a couple of different things here. We see what we saw before. It begins with the word switch. The numeric evaluation is what choice was made for travel method. Choice 1, land. Choice 2, sea. Choice 3, air. If the choice was 1, then we have a second thing we have to evaluate. Now you will see now that I am embedding an if-then structure inside of a case structure. Remember a moment ago, and we see it here. In this example, we nested. We put this if-then structure inside of this. And we put all 5 of, sorry about that. We put all 5 of these if-then structures inside of that structure. This is called nesting. Now, the same way we can nest if-then structures inside of other if-then structures, we can also nest if-then structures in our newly learned structure, case structures inside of each other. In case the travel method is 1, which is the land option. If travel method is 1, in case of 1, then evaluate which land transportation option did they choose. If they choose 1, present the car. If they didn't present or didn't select 1, then they had to select 2 because those were the only 2 options. Display the train. Now, if the selection for travel method, in case the travel method selected is 2, don't even waste time with this if-then. This is the beauty of the case switch structure. That which is irrelevant is completely ignored. Compare that to an if-then structure. If I were to choose this, 6, all of these lines of code are irrelevant. They're false. They will return a failed test. But Ninox will execute them and evaluate them anyway. In a choice or switch structure, as we see here, because the choice was not land, the case is not 1, we'll simply ignore this. We will not waste our time and energy evaluating a test which is irrelevant because we're going on a boat. So the only thing we need to evaluate is what size boat do we want to travel on. Now you'll notice here I used an if-then in case of 1, in case of land travel, but I used an embedded switch in case of 2, in case of sea travel. Remember the first of the 3 benefits of the case. The case is used when there is more than one potential result, more than one potential valid or passing or true result. In an if structure, there's only one valid passing result, and everything else is considered a fail. In the case structure, as we see here, and I'm going to return to table 2 and go take a look at that simple case structure that we built. Here, there are 4 different possible correct results. 1 is okay, 2 is fine, 3 is good, 4 is also good. Any one of these is a valid result. When you have more than one potential valid result, we use the case or the switch. When there is only one valid result, we would use the if-then. So, here, in case 1, we've chosen land. There's only one other valid choice to be made. Car or train. One or the other. If this, or else that. However, when we chose 2 as our transportation method, there were not 1, not 2, but 3 valid true options. We could have chosen the small boat, the canoe, a medium-sized boat, or an enormous yacht. All of those are valid choices, and if there is no choice made, we then can say, we know you're traveling by sea, but you haven't selected a boat yet. Pick your boat size. Now, if we choose air, all of this code will be ignored because it's irrelevant. If travel method is 3, we don't care what kind of land transportation they want. We don't care what size boat we want. We only need to know how far are we going. If the travel distance is 1, which was the numeric value here, travel distance, if it is a 1, that is less than 250 miles. If it's not a 1, then it has to be a 2. Notice I've indicated a default value, which means if I select nothing, Ninox is going to select less than 250 miles for me. So there's never going to be a situation where neither of these choices has been made. If we're traveling by air, which means travel method equals 3, then this choice field, the travel distance field, will be presented. And our only options are less than 250 miles or more than 250 miles. There is no option to make no choice at all. So again, where we have this binomial, bi refers to 2, this binomial current state to evaluate, we again use an if-then. So we see 3 different possible blocks of code, 3 types of blocks of code to be executed in the case or in this switch. In 2 cases, we have an if-then structure in case 1 and case 3. In case 2, we have an embedded switch inside of a switch. And in case of it's not 1, 2, or 3, we simply return a fixed or static text string. This is the additional value, capability, and power of the case structure or the switch structure. We can make it do lots of different things, and we can make it do different kinds of things. Now, remember a moment ago when I said you can't return different kinds of values? You can't have a switch or a case structure that in case of this and that return text, but in case of these other two options return numbers. You can't do that. Well, here, it looks like I'm breaking that very rule. I am returning text here, but in every other instance, here, and throughout these three options, and again up top in case of land, I'm returning pictures. These are not graphics in the sense of a JPEG or a bitmap or a PNG. These are emojis, and emojis are considered text. Therefore, you can copy these little tiny pictures and return them the same way we can return letters and numbers enclosed in double quotes. These count as text. So this gives us a nice graphic element to our user interface. If traveling by air more than 250 miles, I see the airplane. If traveling by land in an automobile, there's my car. And if traveling by sea in a medium boat, there I see the medium boat. And because this is a formula, we have the option to style the results. Now here's a tip. When you are returning an emoji, set your return size to be very large. If you go with normal or even large, the emoji coming back is going to be really tiny. Now it's not exactly enormous if we go with very large, but that's as big as we can make it, and that's a little bigger than it was before. So as long as we're here, let me show you something very quickly. If you go into your browser, and it doesn't matter what browser you use, and you simply type emojis into the search bar, you'll come back with, a little over 363 million results. I like to use Get Emoji, but there's literally millions of places to grab an emoji. Go in, grab the picture you like. For example, if I'm traveling by air, I'm going to return this smiley face. So I'm going to go into my formula, and if traveling by air, which is case 3, and traveling the long distance, which is travel distance 2, more than 250 yards, I'm going to remove the airplane and paste the smiley face. If I have to go by a helicopter, I guess I'm okay with that, but it's not my first choice, so I'm going to be rolling my eyes a little bit because I really would rather be on the plane. I copy one emoji, I paste it. No, it helps if you put it in the right place, folks. Get rid of the helicopter and paste the rolling eyes. Now, because emojis are treated as text, like the letters of the alphabet, they must be enclosed in double quotes. But now we see a new graphic result when traveling by air. When I'm traveling by air and going more than 250 miles, I'm on the plane, which makes me happy. The point of all of this travel silliness, folks, is to understand the value, the application, and the syntax of the case structure, or what we sometimes refer to in Ninox as a switch. We are switching based on a numeric result, and for each numeric result, we are telling Ninox to do a different thing. Whatever we want Ninox to do will follow the keyword case and a number and a colon. And if none of the choices are made, and the choices in this case for travel method were 1, 2, or 3, in case none of those is the case, our last option is to set a default. And then finally, we end the structure. Now, as I said in the previous class, keep in mind, you can declare variables inside of a case or switch. Let x equal my name. But if I attempt to return that value outside of the structure, it's saying field not found because the structure has ended. The value or variable x was declared, was brought to life inside the structure. So the variable's life ended when the structure ended. If I want to refer to variables inside of a case or switch structure, I must bring them to life outside of the structure. X has been brought to life in line 1. It has been assigned the value capital A NDY in line 4. But again, because we are inside the structure when the assignment is made, but the variable itself was brought to life outside the structure, the variable can be used and referred to outside the structure. Just something to remember. The last thing I want to point out and remind you of is what is obviously being presented here. The ability to embed switches within switches. The ability to embed if-thans inside of cases or switches is moving us further and further down the road of what is really called artificial intelligence. As we enable Ninox to evaluate more complex situations, more fields, more values, as more data can be an input to the Ninox decision-making engine, Ninox can give us the right results, can give us the right answer in more complex situations. And as those situations become more and more complex, Ninox begins to demonstrate a higher level of intelligence, artificial intelligence, intelligence that we have given it by virtue of the programmatic code we've typed in, but a form of intelligence nonetheless. The ability to evaluate what is going on around us and make a decision on what to do next based on the results of that evaluation. This is what a structure, a looping structure, or a repetitive structure, and remember there's 4, if then, case of, while do, for next. This ability to use these structures and embed them and stack them and nest them inside of each other is giving us the ability to teach Ninox how to think and how to respond in certain situations. This is an enormously powerful capability, and it is a power we're going to continue to discuss in the next class, where we will focus on yet another repetitive looping structure, the while-do structure. That's going to be it, though, for this class. We've looked at the case structure, or the switch. We've noted that we can embed switches inside of switches. We can embed if-then loops inside of switches. We understand now the benefits of the case or switch structure versus the if-then. It's more compact, it's smaller, and small things move faster than big things. It requires less work to be done, and less work can be done faster than more work. And it allows us to evaluate more complicated environments, environments where there's more than one right answer. The if-then, it was this or anything else, and anything else was a fail. It's either true or it's false. with the case structure or the switch, there's lots of different correct answers, but we can have our default answer in case none of those answers were actually chosen. That is the second of our 4 looping repetitive structures. I hope you enjoyed the class today. I hope you learned something, and I hope you'll join me in the next class in the Ninox Learning Series when we take a look at the while-do structure. Get out there, build some cool things with Ninox, have fun, and join us again in our next class. Thanks very much, and goodbye.